everyone, and welcome to a very special edition of the Kathy and Kevin Show. I wanted to introduce you to a very good friend of mine, Julia, who is a National Geographic explorer and an astrobiologist. Julia, what are you going to teach us today?
Hi, Kathy. Nice to meet everyone. Today I'm going to be teaching you about the size and the scale of our solar system and the universe.
Wow, so for those of us watching who don't know, what is the solar system and what is the universe?
Great question. So the solar system is kind of our local neighborhood. Anything that goes around the sun is in our solar system. And the universe is the big thing that holds everything we see in space. Any galaxy, any star, that's all kind of held by the universe, or it is in the universe.
Wow, that's a big topic. I can't wait to hear what you have to tell us. So where are you and what is it that you do?
I live in Oakland, California, and I work at a place called the Berkeley SETI Research Center.
What does SETI mean?
SETI, S-E-T-I, stands for the Search for Extraterrestrial Intelligence. Now, my day job, where I go to work, I look for signs from ET. So you might have seen the movie E.T. where E.T.'s phoning home. We're trying to listen for any signals of extraterrestrial technology sending messages in the direction of Earth. And we do that using giant radio telescopes like this and optical telescopes like this one.
So have they actually found evidence of any aliens?
That's something that requires extraordinary evidence to prove that there is aliens out there. We hope to. That's why we do what we do. Is we want to say that for sure that we've found something for real out there.
And I guess it's hard because you don't know exactly where to look, and space is pretty big.
Yeah. So space is really, 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 really big. Take a guess what those things are kind of flying at the screen.
Those of you watching, what do you think we're looking at?
What you're seeing are galaxies.
Wow, so every one of those little dots is a galaxy?
Yeah, each of those blobs are galaxies.
And what exactly is a galaxy?
So a galaxy is something that looks like this. It's a collection of gas, stars, dust, and anything that goes around a star, like planets. We call these spiral galaxies. Here are 3 examples of spiral galaxies. You can see they kind of have a spiral whirly-pool look. Now these are beautiful galaxies, and these contain lots and lots of stars. And we're going to look at some other types of galaxies. This one is called a barred galaxy, a barred spiral. It has a bar in the middle. You don't need to remember all these facts. But this one is what we think our galaxy looks like, sort of. We think we have a barred spiral galaxy. This one is called an elliptical galaxy. Now look how different that looks. And this one is funky. This one is what we call an irregular galaxy. But I just wanted to show you what kinds of galaxies there are in our universe.
And what's the name of our galaxy?
We live in a galaxy called the Milky Way galaxy. And I want you to put on your thinking caps, and I want you to take a guess of how many stars are there in each of these galaxies. We believe that there are about 400 billion stars in each galaxy, give or take. We know our galaxy has about 400 billion stars in our galaxy. Some are, of course, much bigger than our galaxy, and some galaxies are smaller than our galaxy. So this is what we call an average, kind of somewhere in the middle. So that's a lot. Can you even think about how many stars that is? It hurts my brain to really think about how big that number is. Now, when we go outside in the night sky and we look up, on a clear night, we can only see about 1,000 stars on a really clear night. So to think about, there's 400 billion stars in our galaxy is like, whoa, I can't even. So we just learned about galaxies and how many stars are roughly in each galaxy. My next question for you, how many galaxies are there in the universe? Now, our universe is a really big place. The universe is what holds everything that we see in the sky, in space. How many galaxies do you think there are in our universe? So are you ready to learn how many galaxies there are in the universe? It's about the same number, 400 billion galaxies in the universe, give or take. You know, we don't know the exact number, but we can make a pretty good estimate on how many galaxies are in the universe. So space is truly really big. And in order to think about, you know, life out there, is there life out there around one of these stars and perhaps one of these galaxies? It's like, where do you even start? So I like to start somewhere really small. In order to answer these really big questions, we need to start really small. So we're going to start close to home, and we're going to think about the size and scale of something we're familiar with. So we're going to make a model of something we're familiar with to even think about the size and scale of the universe. By that, I mean we're going to take something we know, like a car, and we're going to shrink it down to like a model car. So we're taking something pretty big and we're shrinking it down to something small that we can understand a little bit better. So we're going to start by thinking about size. We're going to think about the Earth and the moon, because we live on the Earth. We kind of get it. We can see the moon in the sky sometimes. I'm going to show 4 marbles, and I want you to take a guess how big the moon is compared to the Earth. So you're going to pick 1 to be the Earth and 1 to be the moon. So here are your 4 choices. We've got number 1, this really small kind of marble. It's about half an inch, around that size. We've got number 2, kind of your average marble size. Number 3, this is about 1.5 inches in diameter or across. And then number 4, this big shooter marble, if you can see that. Pick 1 to be the Earth, 1 to be the moon. Okay, so here are our choices. And the answer is that number 3 is the Earth and number 1 is the moon. Now give yourselves a pat on the back if you got that right. And if you didn't get that right, that is a-okay. Not many people get it right. But here's one secret I'm going to give you. You can fit 4 moons across the diameter of the Earth. That's one way to kind of figure this out. No matter how big or small your Earth and moon are, if you can get them to that right kind of proportions, then you know you've got it. So now that we have our Earth and our moon, how far apart are they really? Your next question is make a guess of how far apart these need to be in order to be kind of the same model, the same scale as they are in real life. So we're going to shrink down the Earth to this size and we're going to shrink down the moon to this size. We can guess in inches or meters or centimeters or even, I don't know, a hand width apart, whatever kind of scale you want. So how far apart is this Earth and this moon away from each other in this scale? So the Earth and the moon to this scale are about 1 meter apart. And 1 meter is a little bit more than 3 feet, so 36 inches, pretty far apart. So we're gonna look at an example of what that looks like. So if I were to shrink down the Earth to this size, the moon would be this size, and they would be this far apart. We don't actually understand how far away the moon really is. It takes about 3 days for those Apollo astronauts to go from the moon all the way from the Earth to the moon. It takes about 3 days in a really fast rocket. So that's how far away the moon is. But now you know. Okay, we're going to think about scale in terms of the rest of the solar system. The star in our solar system is the sun. The first planet we have is Mercury, then Venus, Earth, Mars. In between Mars and Jupiter is the asteroid belt. Then, of course, the biggest planet, Jupiter, Saturn, Uranus, Neptune. Then we have another belt called the Kuiper Belt. And in the Kuiper Belt is Pluto, and in the asteroid belt is Ceres, and those two are dwarf planets. So this is our solar system, and I want you to take a look. This is what we call a model of the solar system. Now, I want you to see if you think there's anything wrong with this picture. So if you can see Jupiter over here, Jupiter is not supposed to be bigger than the sun. And look, it looks like the Earth is about the same size as the sun in this model. So we know this is not a great representation, a great model of the solar system. So we're going to try and figure out how far apart is the solar system. So we're just talking about the Earth. Remember, it's about the size of kind of like a big marble. And if the Earth was the size of this big marble and the moon was the size of this little marble, the sun would be huge. It would be about 11.5 feet across. So it'd be very, very big. Now I want you to take a guess, knowing that how big the sun is to this scale and how big the Earth and the moon are. Take a guess with maybe your hands, how big the rest of the planets are. I want you to take a guess how big Jupiter is. If Earth is this big, how big is Jupiter? So Jupiter, you know those big beach balls that are about this big across? That's how big Jupiter would be. 3 Earths can fit inside the red spot of Jupiter. So that's how big Jupiter is, and Jupiter is the biggest planet in our solar system. To that scale, Mercury would be about a little smaller than the second biggest marble. Pluto would be smaller than the moon, and Venus would be about the same size as the Earth, and Uranus and Neptune are about maybe the size of a big softball, something like that.
And how about the size of other things in the universe? Can you show us how big they would be in relation to each other?
Yeah, so we're going to go from something small to something really big. Ceres is a dwarf planet, which is smaller than the moon. Callisto is a moon of Jupiter that is about the same size as Mercury, the planet. How crazy is that? Now, the next biggest thing is Mars.
I like how you can really tell why it's called the red planet in this picture.
Yeah. So Earth and Venus are about the same size. And this next thing is something funky. This is what we call an exoplanet, a planet that goes around another star. This is not in our solar system, but it's the closest thing we found out there to the size of the Earth. So we got Neptune and Uranus. They're about the same size. Saturn, take a look how big Saturn is. Jupiter. Now, what do you think is coming next? Do you think it's the sun? It's not our star, but it's a very small star. One of the closest stars to our sun, called Proxima Centauri. Now, this is the size of our sun. Look how small the rest of the planets are in comparison. Here's one of the brightest stars in the night sky called Sirius A. You can see it near the constellation of Orion. Vega is another very bright star. Check out this star, Arcturus. Now check out our sun, which is this yellow one right over here. Actually, I think our sun is a lot smaller. So there's a lot bigger stars out there. Now we're gonna see a few more things before I stop this video. But there's a few more other things in this video that are really cool, but I just didn't want to go into them. Betelgeuse is in the constellation of Orion. VY Canis Majoris is another huge star. Now this is one of the biggest stars that we've seen, UY Scuti. So how do you feel now about our place in space? Think about that for a second. Some people have told me they feel small.
I feel really tiny.
I feel really tiny. Yeah, so when I think about how small we are in the context of the universe, it makes me feel really, really tiny, because I know we live in this tiny planet around a small star in a galaxy among 400 billion other galaxies, and that makes me feel really tiny. We call that the cosmic perspective.
And it's kind of crazy to see how big some of these clouds and galaxies and nebulas are.
Yeah.
So we know how big things are in relation to each other, but how far apart are they? Like, for example, in our solar system.
So we're going to take a look at another picture of the solar system. Now, the sizes here are pretty good. This is how big those inner rocky planets would be compared to the size of the sun if it were about this big on the left here. This is about how big Jupiter would be, and the Saturn, Uranus, and Neptune. But what about the size? Is this a good model? Are they the right distance away from the sun? Turns out the answer is no. The distance between the planets is so great we can't really fit them on the same page. So the distance, if we were to go back to our sun here, 11.5 feet across, it would be a football field and a half to get to Mercury. So that's about 154 meters, or 154 big steps away from the sun. That is the first planet. So no wonder we can't really show how big and how far away things are in a single image like this. So it's really tricky.
We know the solar system is huge, so the Milky Way must be big too. How big is it?
Yes, the Milky Way is really, really big. I always forget how big the Milky Way is across, but I think it's like 100,000 light years. It's pretty big.
Wow, that's huge. Okay, so Julia, if you have the time, I do have some questions from some kids.
Great. Yeah, go ahead and ask them.
So the first question is, I know Earth has a moon, but are there other moons in our solar system?
Yes, we found 79 moons around Jupiter. I think Saturn has like 63. A lot of the planets have moons. We have one moon. Venus has 0 moons. Mercury has 0 moons. Mars has 2 tiny moons. So yeah.
So staying with the moon theme, how many people have actually been on the moon?
So 12 humans have walked on the moon, and that's it, only 12. And all of them were men. So I'd like to see a woman on Mars. I think we should have some gender diversity there.
I totally agree. I would love to go to Mars. Another moon question, does the moon have gravity?
Yes, the moon does have its own gravity, and the moon, so the moon goes around the Earth about once every 28 days, and the Earth is tugging on the moon with its gravity, and the moon, even though it's a lot smaller, which has a lot less gravity, has about 1/6 of the Earth's gravity, it still tugs on the Earth a little bit. And that gravity that the moon, the gravity that the Earth feels from the moon gives us our tides. So we can see the effect of the moon going around and the effect of that gravity by the tides going in and out every day.
Here's an interesting one. If the Earth had no gravity, would the moon float away?
Wow, what a fun question. Yeah, so if the Earth had no gravity, we wouldn't be here. So it's hard to think about. It's a fun thing to think about, though. If all of a sudden, for whatever reason, we were able to turn the gravity off on Earth, the moon probably would float away, or it would go somewhere else, because it wouldn't have the tug of gravity from the Earth keeping it around the Earth. It's the same kind of idea of why we're going around the sun, because the sun has a lot of gravity.
And what about Mars? Does Mars have gravity?
Mars has gravity, more than the moon. I think it's about a third the gravity of Earth. So you could jump 3 times higher on Mars than you could on the Earth, and you could jump 6 times higher on the moon as you could on the Earth.
Well, Mars definitely sounds like it would be such an interesting place to go visit. It'd be fun to jump around, and it'd be interesting being the first woman there. How hot is it there?
How hot is Mars? Mars is actually cold. Mars is, it depends where you are on the planet and what time of day is it. Mars has a really similar day length to Earth. Our day is about 24 hours. Mars is about 24 and a half hours, a little bit longer than the Earth's. But it's farther away from the sun, and it doesn't have a big atmosphere. So our atmosphere kind of acts as a blanket. If you have a really, really big blanket like Venus, you can have really hot temperatures. On the surface of Venus, it's about 860 degrees. Earth, it's on average, I think, about maybe 60 degrees. And then on Mars, I know the temperatures can reach down to like minus 120 degrees Celsius or Fahrenheit. But because Mars doesn't have a big atmosphere, its temperature can vary from cold to hot. But it can be about 68 degrees Fahrenheit. But yeah, usually it's pretty cold. So you've all probably seen dry ice before. It's frozen carbon dioxide. On Mars, you have a lot of frozen carbon dioxide at the poles. That's how cold Mars is. So pretty cold. Okay, and it could be as cold as minus 243 degrees Fahrenheit. So even colder than I initially thought. So that's a lot of fluctuation, a lot of change in the temperature.
And here's another temperature question. What about Jupiter? Is Jupiter hot or cold?
Great question. Is Jupiter hot or cold? Well, it is far away from the sun. So the kind of the top layers of Jupiter are pretty cold. It's really cold out there. I would say probably minus 200 degrees way out there.
So probably not the most comfortable planet to visit.
Yeah.
So it definitely sounds like Mars and Jupiter and all these other planets would not really be too comfortable for humans to go and live on.
Yeah. So the reason why I love Earth so much is that it's just far enough away from the sun that it's not too hot and it's not too cold. We don't want to be close enough that it's just really, really, really hot, and we don't want to be too far away. Like even on Mars, it's pretty cold. I wouldn't really want to live there unless I have a lot of protective gear and things like that. Plus, you can't breathe the air on Mars.
Well, I guess it's a good thing that we all live on Earth then. Well, Julia, I wanted to say thank you so much for coming and teaching us today.
Yeah, thank you so much.
We had so much fun, and we really appreciate you taking the time out of your schedule to teach us all about space.
So happy exploring, everyone. I hope you learned one or two things from this. This was a lot of fun.
And thank you, everyone, for watching. We'll see you next time.